Alright, so this is the Chapter 10 test review. So A days, you're going to have this test on Friday. Today should be Wednesday. And B days, this should be Thursday, and you're going to have your test on Monday. If Monday, I'm not sure if Monday is a part of the weird bell schedule day. If it is a weird bell schedule, then we might have to adjust it. But for right now, just plan on the test being on Monday. I'll update it with reminds. Also, before I get started, I want to remind you that today during advisory, or not today, Thursday and Friday during advisory is the review, or I'm sorry, retakes for the section target 7.3 and 7.4 target review. So the review, and then after school you can go to either teacher's room, probably Miss Catania's, I think she's P16, to get to take the test after you've gone to one of the reviews. So she'll be offering the review on of one of the targets, and Miss Rucker directly across from me will also be offering a review. And you can either ask myself for the passes, or either Miss Catania or Miss Rucker for a pass. And if you forget to do it today, then you can do it Tuesday or Thursday morning. Miss Rucker's there pretty early, and she'll write you a pass. But again, you need to get in and get the pass, and I have written down on my board who's reviewing what target. Okay, so let's get started with number 1. So everybody should have the practice test, and again, it's okay with me if you want to do it on your own, and then you can just, like, on your phones, you can follow along and listen on your earbuds, so that way you can stop and start whenever you like. Or you can listen in class, but again, you have to clear that with the sub. And if you are using your phone, it has to be to watch this video and everything else. And also make sure you get a calculator and put the calculators back when you're done. Okay, so it's asking for the measure of this minor arc. So the minor arc would be the short way around from A to B, and remember, the measure of the arc is always equal to the angle. So minor arcs, we use 2 letters, so it's going to be AB, and it's equal to the measure of the angle. In this case, it's 130, so this would be AB 130. Nice. And remember to stop and start whenever you want, or talk to the sub about it if you're running through, but I'm not going to cause to wait. Okay, so now it's asking for a major arc, and remember, a major arc is 3 letters. So the major arc would be this arc right here. So we go through A and pass through D and stop at B. So this is the long way around. So if this arc is 65, the minor arc is 65, then the major arc would be 360 minus 65. And if I do the math correctly, I believe that is 295 degrees. So, and the name of the arc would be ADB. So it'd be arc ADB, and be 295. And it looks like there's no good choice. I think this, hold on, let me pause and I'll see what the mistake was. I think yours is actually right. I think I forgot to change it on this. So hold on a second. Let me double check. Okay, I got it fixed up. It should have been ADB 295. And I did fix it on the test I passed out to you, but clearly I did not fix it here on my slideshow. Okay. So sorry about that, and it is arc ADB, and it's 295. Okay. So next we have to identify a semicircle that contains C. So there's a few of them. There's this semicircle, and actually I do think that might be the only one. and that would be semicircle ACB. So there it is. So there's just one. Okay, so we're looking for segment AB. So segment AB is this line, and we notice that it touches a circle in two places, which makes it a chord. But since it's a chord that goes through the center, a better name for it is a diameter. So AB is a diameter. Okay, now CB, get a different color for this. Purple. CB right here starts at the center and goes to the edge. So a segment that starts at the center and goes to the edge is, yes, you guessed it, a radius. Now AG is a line, and so it touches a circle in two places. I guess I'm going to use purple again. I meant to change colors, but I forgot to. But it touches a circle in two places, and it keeps on going. It punches through, so that would be a secant. And then line DE is this line here, and that touches a circle in only one place. So line DE would be a tangent line. And I didn't ask this, but this line sitting it right here would be a chord, and point B right there would be the point of tangency. Okay, next slide. So we need to calculate the length of the radius. So this is a radius. If AB is 6 and AO, this whole way, is 9.8. So again, since this is tangent to a circle, that makes this a right angle, and we can use the Pythagorean theorem, our favorite. Leg squared plus leg squared equals the hypotenuse squared. So then you have 6 squared plus, r squared, because that's the radius, we don't know what that is, and then the hypotenuse is 9.8, so 9.8 squared. So I get 36 plus r squared equals, and then I have to figure out, using a calculator, what 9.8 squared is. And that looks like 96.04. So 96.04, and I'm going to subtract 36, and I get r squared equals 60.04. I'm going to take the square root, and I'm going to get r is square root of that, about 7.7. Okay, so good. Next slide. We want to know if this is tangent to the circle. So again, if this is tangent to a circle, this angle right here would be 90. And we don't know if it's 90 or not. So to find out if it's 90, we're going to do the Pythagorean theorem, and if it's a right triangle, then this would have to be 90. So if this was a right triangle, the hypotenuse would be 13. So we want to know if the other two sides squared equals 13 squared. So I'm going to do 5 squared plus 11 squared. And we get 25 plus 121. And I want to know if that equals 169. And 121 plus 125 looks like it's 146, which does not equal 169. So this is not a right triangle. So AB is not a tangent line. Okay. So this is, remember the ice cream cone picture, and we have a theorem that says if I have an exterior point and there's two tangent segments drawn from that same exterior point, then those two tangent planes are equal to each other. So we're going to set these two equal. We're going to say 3x minus 4 is equal to 2x plus 1. And I'm going to do the algebra, so I'm going to subtract 2x. And I'm going to have x minus 4 equals 1. And then I'm going to add 4. And I will get that x equals 5. Now the question is to find the value of x and to find the length of AB. So to find the length of AB, I'm just going to plug in. So remember, AB was equal to 3x minus 4. So I'm going to replace the x with 5, and I get 15 minus 4, which is 11. Okay. So next we're going to use the same ice cream cone theorem here. Let's just first label all our points. JA is 10. And AL is 6, and CK is 8. So what it's asking for is the distance around this triangle. So we know that this side is 16, 10 plus 6, right? But this side we don't know either of the segments, and this one we don't know this one. Except, remember, we have that theorem that said two tangent segments drawn from the same exterior point are equal. So what that means is if this is 10, then this is 10. And then here, if this is 6, so this is 6 because they told us it was 6, then these two pieces are equal, so that is 6. So that makes this side 14. And then we were told that this was 8, right? This was 8. So that makes this 8. Right? Which makes this whole side 18. So my perimeter would be 18 plus 14 plus 16. And 14 plus 16 is 30, plus 18 is 48, so my perimeter would be 48. Okay, so we have to describe and correct the error. So the problem here is that, remember, we need a right angle, but it needs to look like this. So my right angle needs to be at the edge of the circle, not up here at the center of the circle, right? So if my right angle was here where it's supposed to be, now I'm fixing it. Let me change colors quick. Then the longest side, which is 25, would be the hypotenuse. So this should be 25, and this should be 24. And that should be a right angle, so it would really be this picture. Then, this is true, 25 squared plus 7 squared does equal 24 squared, but the hypotenuse would be in the right spot, and then it would make sense. Okay, describe and correct the error in naming the major arc. Well, right here is the arc, and remember, major arcs are 3 letters. So this right here is the minor arc, and we're looking actually you. Okay, so I was getting a new color. So my new color will go with the green. So my new color, so the major arc is actually this arc. And if I go the long way around, and so the short way around, it's B, D, and then C. So I should say arc B, D, C. So a minor arc has 2 letters, a major arc has 3 letters. Okay, so this has 2 questions, and I think on yours I made 2 columns. I think one for the type and one for the measure, and I don't remember which I put first. Let's say that this one was measure and this one was type. So JK, well, this is arc JK right here. Oh no, not to there, just to here. That's JK, just to here. And that is definitely a minor arc, so I'm going to put minor here. Now it also asked me to find the measure, right? So I'm going to do a little bit of looking here. Get the highlighter. I want you to notice that this is a semicircle. And I know that this much, the semicircle is 180. So, since this is 180 degrees, let me put my pen out again. Green. And I don't want the green highlighter, I want the green pen. That would be 72. And this arc would be 30. And the semicircle itself is 180. So if I add the 72 and the 30, I'm going to get 102, and I'm going to do 180 minus 102, and that should be 78. Let's just double check. 180 minus 72, 78 degrees. So this is definitely 78 degrees. Okay, so then JL. So I think I'm gonna get rid of this. So we have something fresh to work with. But I am gonna put in what I did find out before, because that might be useful, that this was 78 degrees. And then I'm gonna switch colors, and it's asking for JL. Okay, so JL is this arc here. And that's pretty straightforward. I know from here to here is 78, and from here to here is 30. So JL is just going to be 78 plus 30, which is 8 and 73 is 10, so 108. This would be 108, and again, that would be a minor arc, since it's under 180. And then JHL, so JHL is starting at J and going all the way around, long way around to L. So that's nice. It looks like it's everything but the purple arc. And the purple arc is 108, we just found it, right? So this would be 360 minus 108. So I believe that's 252, 360 minus 108. And 252 is definitely a major arc. Now, there are different ways to solve all of these. This one, I actually knew that this was 180, so I could have done the 180 plus 72 also. That would have worked as well. Okay. Number 12, again with the arcs. This time we don't have to tell the type, we just have to find the indicated measure. So the first one we're looking for is QR. Okay, so if I look at this, the first thing I notice is that this right here is a semicircle. So this part right here, this part right here, has to be 180 minus 42. So 180 minus 42 is 138. So QR would be 138 degrees. Guess all these should be in degrees. Okay, then PQ. Well, that's easy. These two angles are equal. This is 42, so that makes this angle 42, which also makes my arc 42. So this is 42. And then TS is a little more difficult, but really not too bad. Let's erase some of this stuff. And then I'll use people. So this was 138, let's not forget. I don't know if we even need it. Okay, but this right here is a semicircle. And we're looking for this. This is what we don't know. And I know that that's 64, and that's 42. So if I add these up and subtract from 180, because a semicircle is 180, I'll get the answer. So 64 plus 42 is 106, and 180 minus 106 should be 74. Let me just double check. 180 minus 106. 74. Alright, next slide. Oh, the easy stuff. The center and the radius. So let's write the equation down again. It's x minus h squared plus y minus k squared equals r squared. Okay, so remember we do whatever's in the parentheses is opposite, and you always have to do what's with the x first. Again, I would put this in my notes if I were you. I would put this formula and example in the note card that you get to use on your test day. Okay, so what's the opposite of negative 8? This is A. So the opposite of negative 8 is positive 8. And then what's with y? Nothing, so that's 8, 0. And the radius is 3, because I do the square root of 9. Okay, so for part B, what's with the x? It's 2, but I do the opposite, so it's negative 2. What's with the y? Negative 4, but I do the opposite, so 4. And then the square root of 36 is 6, and my radius is 6. So pretty easy. Okay, now here we're writing the standard equation of a circle, and again, I may as well write the formula again. X minus 8 squared plus y minus k squared equals r squared. So let's look at A. It looks like that's my center right there. So my center is 0, 0. And my radius, that's 2, so that looks like each of these is 1. So my radius is 1, 2, 3. So my radius is 3. So plugging that in, I get x minus 0 squared plus y minus 0 squared equals 3 squared. Well, x minus 0 is just x, so I can write x squared and y squared, and 3 squared is 9. You don't have to write that intermediate step. You could just skip to this if you wanted. Okay, and this one's a little different. In this one, the center is -1, +1. And the radius looks like it is 2. So remember, I have to do the opposite. So I have squared plus squared equals 4, because 2 squared is 4. So x and y, now this is a -1, so the opposite of -1 is +1. And this is a 1, and the opposite of +1 is -1. So that is my answer. Okay, now we have to graph the circle. So again, we have to find the center and the radius. So the center is 3, -2, and the radius is the square root of 16, which is 4. So we start by plotting the center. 3, -2. Only I plotted that wrong. Sorry about that. So let's try that again. 3, -2 would be right here. And then from there, I do the radius, and the radius is 4. And it looks like I sort of ran out of room, so we'll estimate it. But 1, 2, 3, 4. So I go up 4 from the center. Then I go back to center, and I go left 4. 1, 2, 3, 4. And then I go back to center, and I go down 4. And then from there, I go right 4. And it looks like right 4 would put me about right there. And then, you know, you're going to draw your circle. And I know mine looks pretty lousy. But as long as yours is not square, like, then I'll be fine with it. So that would be the answer. Okay. Next. Okay, a student says the center of a circle is -2, 3. What is the student's error? Well, remember, we have to do the what? Opposite. So the opposite of -2 is 2, and the opposite of +3 is -3. So the center really should be 2, -3. Okay, so the student's error would be that they didn't change the signs. And then got the center wrong. Alright. Okay, number 17, we have to calculate the circumference in terms of pi. So that means you're going to leave your answer in terms of pi. You don't have to, so I'm looking for the exact answer. So remember, we have two formulas for circumference. We have d pi and 2 pi r. So we're going to do d pi, since we're given that 4.3 is the diameter. Okay, so my circumference is 4.3 times pi. So that would be my answer, 4.3 pi. Easy. Okay, calculate the arc of xpy to the nearest tenth. Okay, so remember the formula for arc length is the measure of the arc over 360 times the formula for circumference, which is 2 pi r. So here we know that the radius is 18. Now I know that this is 90, so this is 90. But I'm not looking for the length of xy, I'm actually looking for xpy. So I have to find what this arc is. Well, that would just be 360 minus 90, which is 270. So the measure of my arc would be 270 over 360 times 2 times pi times 18. Now on your calculator, you just multiply that out. And it says the nearest tenth, so we don't want the exact answer. We want the times pi answer. But first of all, we'll just figure out what the exact answer is. So 270 times 2 times 18. Remember, we multiply all the numbers that are on top. And that gives me 9720. And then I'm going to divide that by 360. And I get 27, and I'm going to tack on a pi. So my exact answer is 27 pi. They're not looking for the exact answer, they're saying calculate it to the nearest tenth. So on my calculator, I'm going to do 27 times the pi button, and I will get 84.8. So that would be 84.8, and this is length, so that would be meters, not meters squared. Okay, so this wants the length of arc AB and the length of arc ACB to the nearest tenth. Alright, so we'll start with AB. So again, it's the measure of the arc over 360. Length is the measure of the arc over 360 times 2 pi r. So my arc is 30 for AB, and my radius is not 28, 28 is the diameter, so my radius is actually 14. Number 28 divided by 2. So, plugging in the formula, I know that the length of arc AB would be 30 over 360 times 2 times 5 times 14. Then I'm going to work that out, and it says the nearest tenth. So on top I'm going to do 30 times 2 times 14. And on top I'm going to end up with 840, and then I'm going to go ahead and divide that by 360. And I'm going to get a decimal, 2.33333. So AB would be 2.3333 blah 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 pi. So I'm going to go ahead and multiply that by pi, and I'm going to use the pi button on my calculator, and I'm going to get 7.3. So my answer for AB would be 7.3 feet. Okay, now we also want to find the length of ACB. So for ACB, I need to know the length of this arc. Well, if this arc is 30, this one has to be 360 minus 30, which is 330. So it's going to be 330 over 360 times 2 times pi times 14. And 330 times 2 times 14 is 9240. So I get 9240 And I'm going to divide that, by 360 and multiply by pi. I don't usually write that step, but that's okay. So 9240 divided by 360 is also a decimal. This one's 25.66666. And then I'm going to multiply that by pi. And I get 80.6. And this would be feet. Okay, another way we could have done it is found the area of the length of that arc, then found the circumference of the whole circle and subtracted that 7.3 out. So if you add the 7.3 and the 80.6, you actually get 87.9. So if I did 28 times pi on my calculator, that would be the circumference of the whole circle. What do you know? I get 87.96. So it would be awfully close. Okay. Okay, but the two answers that we really wanted was the 7.3 and the 80.6. And if you notice, you can add those up and get 87.9. The 6 is if I had taken these to the nearest one more decimal place, I would have gotten the 6. Okay. Alright, so now we have to convert 26 degrees to radian. So remember the formula is so to remember, you multiply by pi over 180. So you take your angle in degrees and you multiply it by pi over 180. So my angle in degrees is 26 degrees, and I'm going to multiply that by pi over 180. Okay, now the degrees cancel, and then I can do some simplifying. So 2 goes into both 26 and 180, so when I divide 26 by 2, I get 13, and 180 divided by 2, and I get 90. Oops. So it looks like 13 pi over 90. Now again, on your calculator, you could do 26 divided by 180, and then math, which pulls up the fraction button, and then enter and enter again, and you should get 13 over 90, and don't forget to tack on the pi, so it'd be 13 pi over 90. Okay, so to convert 2 pi over 9 from radians to degrees, you do the opposite. So you take your angle in radian measure, and you multiply by 180 over pi. So my angle in radian measure is 2 pi over 9, and I'm going to multiply that by 180 over pi. Now the pi's cancel, and then I could do a little bit of canceling here. 9 goes into 180. 9 divided by 9 is 1. And 180 divided by 9, I believe, is 20. 20. And then I'm left with a 2 and a 20 on the top, and that was degrees. So this would be 40 degrees. Okay, so now we have to find this area of a circle with a radius of 6.88. Okay, so remember the formula for the area of a circle is pi r squared. Well, I know the radius is 6.8. So I'm just going to plug that in. And this doesn't clarify whether I want the exact or the decimal. On the test it will say. If it doesn't say, then it's up to you. I'm going to do both. So pi and then 6.8 squared. So on my calculator I'm going to have to figure out what 6.8 squared is. And it is 46.24. So my exact answer would be 46.24 pi. And that would be feet squared. And then if I wanted to multiply, that's kind of messy. Let's try that again. Okay, and then if I wanted to find the approximate answer, or to the nearest tenth, or what have you, I would do 46.24 times pi. You okay? Oh. My husband's coughing. Alright, 145.3. feet squared, or square feet. Okay, just I think a couple more, so let's see if we can get through this. Again, it's an area, but this time I have the diameter. So remember, A is pi r squared, and there's no diameter formula for the area, so I have to figure out what that is first. So I'm going to need 19.2 divided by 2. That will tell me what my radius is. And that would be 9.6. So my radius is 19.2 divided by 2, which we said was 9.6. So again, it doesn't say how it wants it, so I'm going to do it both ways again. 9.6 squared and 9.6 squared is 92.16. So my exact answer would be 92.16 pi. And my approximate answer would be 92.16 times pi on the calculator, and that would be 289.5. And these would be centimeters squared, because it's area. Okay, now this time it wants us to find the radius, and we're given that the area is 80, so we have to work backwards here. So I'm going to write the formula down. A equals pi r squared. Okay, so I know the area is 80, so I do pi r squared. And I have to get r squared by itself, so I'm going to divide by pi. So I get r squared equals 80 divided by pi. And 80 divided by pi is 25.4647, blah, blah, blah. So 24.464, blah, blah, blah. There you got it, right? So I'm going to take the square root of that. So on my calculator, I'm going to do the square root of that. And remember, you can do the second square root and then second answer to keep it stored in the calculator, and you get 5.04, so it would be pi, and then the nearest 10. So r would equal 5 centimeters, and radius is distance, not area. So it's not squared, it's just centimeters. Okay, now we have to find the sector of the area of the sector formed by angle JLK. So we're talking about this sector in here. Okay, so remember the formula for the area of a sector is the measure of the arc over 360 times the area formula, which is pi r squared. So the measure of my arc was 125 divided by 360 times pi times 13 squared. So I get 125 over 360 times pi times 169. So I'm going to definitely do all this on my calculator. I'm going to do 125 times 169 on top. And I get 21,125. I'm going to divide that by 360. And I'm going to get like 58.7 pi. So my exact answer would be about, would be about, I'm rounding 58.68 to 58.7. So it will be a little off, but 58.7 pi. And my approximate answer would be, I would actually multiply that out, so I'd hit times, and then the pi button, and I get 148.4. So about 188.4 inches squared. Okay, next. I think this might be the last one. Okay, so this one we want the area of the shaded region. And, you know, I just want to tell you that this picture, we just took a picture of out of the book. So it was easier to draw. On your test, it's going to be the opposite picture. So on your test, it's going to look like this. It's going to have this part be shaded, and it's going to ask you to find the area of the unshaded region. So you'll be finding the area of the white region, okay, on the test, because I couldn't draw it the other way. Okay, so really it's not that hard. We're going to find the area of the big circle, and then I'm going to subtract out the area of the little circle, and that's going to be my answer. So it's the same thing over here. It's going to be the area of the big circle minus the area of the little circle, right? Because I couldn't draw the shaded circle, or the outside part shaded and the inside part white, so I had to do it in reverse. Did you hear me say Urkel, like Steve Urkel? I meant to say circle. Okay. I hope you're all having a good laugh. So the small circle, the area is pi r squared, right? Well, my radius is what? 3. So that'd be pi times 3 squared, which is 9 pi. Now I'm not going to multiply that out, and I'll show you why in a second. I'll multiply it out in a little bit, but right now I'm going to leave it as 9 pi. And my big circle is pi r squared, but the radius of the big circle is 17. So that would be pi 17 squared. And 17 squared is, I think, no, I did it wrong. I think it's 189, not 289. Ooh, okay, sorry. Let's try this again. Let me double check on the calculator. 17 squared is, 289. I was wrong. 289. So I was right all along. So I get 289 pi. So the area of the shaded region would be 289 pi minus 9 pi, which should be pretty close to 280 pi. And if they want that's the exact answer. If they want to the nearest tenth, it'd be 280 times the pi button, and that would be 879.6. So, or 879.6. So you might say, well, why would I ever need the area of a circle with a hole through it? Well, a washer, you know, for bolts and screws, has a hole in the circle, and if you had to make the washer, you would need to know how much sheet metal you'd need to make the washer. Okay. That is a washer. Alright. There's probably other applications, maybe donuts, except those are 3-dimensional, not 2, so it'll be a little different. Okay, I think I saw that there was another slide here, so I should investigate. Sure is, it's an error problem. You have to find where the area is. Okay, so your class wants to find the area of the sector of a circle. So let's stop there and look at the formula. Oh, I did change this on yours. So, give me a second. So pause. Okay, so here I changed it to this formula. This is what yours said. Mine, I forgot that I changed it and I didn't change it on the screen. But I have fixed it, so it should be fine. Let me get a pen up. Okay, so the area of a sector is definitely the measure of the arc over 360 times pi r squared. So it does look like we have the formula correctly, right? And my arc is definitely 150, so I'm going to plug the 150 in here, right? Okay. And then it says times pi times 6 squared. So remember, that has to be the radius. The problem is, it tells me the diameter is 6. I need the radius. So if my diameter is 6, my radius should be 3. So this should be 3. Okay, so the error is they have the wrong diameter, or they had the wrong radius. And to fix it, we're going to do 150 over 360 times pi times 3 squared. So that'd be 150 over 360 times 9 pi. And that would be, when I multiply that all out, 150 times 9 divided by 360. 150 times 9 is 1350 divided by 360 is 3.75 pi. And 3.75 times the pi button is 11.8. So my actual answer would be 11.8 centimeters squared. And I believe that is the final slide. Let me just double check. Yep, that's it. Alright, be good for the sub, study for the test, and don't forget to get your passes for the retakes.